Today's video starts on page 5 of our Chapter 9 notes packet. We'll actually be covering pages 5, 6, and 7. So there's really 3 things we're going to come away with today. We're going back to our trig functions that we started the chapter with, sine, cosine, and tangent. We'll be looking at angles as rotations placed on the coordinate plane. And you'll be learning and having to memorize a few things. First thing we're going to do is look at the unit circle. The unit circle is a circle with its center at the origin and its radius of length 1. All right. So here we have a diagram of the unit circle. It's not shown here, but the point up here would be 0, 1. All right. Here, that would be negative 1, 0. This down here is y value of negative 1 and x value of positive 1. All right, so this is our unit circle. Right? We've got our 4 points of radius 1. Now, what we have here is we have this angle theta, right? And we have a radius drawn from the origin to a point on the circle. So what is the length of this radius? Well, it's a radius of 1. So r equals 1 here. Now this point xy, what are the coordinates? All right. What we're going to do is from the point xy, if we drop a perpendicular that is drawn here, okay, and we just focus on this as being a right triangle, the radius of our right triangle is the hypotenuse. Right? It's opposite the right angle. And in relation to our angle theta, this side here is opposite it. And our side that makes up this portion of the positive portion of the x-axis is the side adjacent. Now, how can we represent the side opposite? What is this length? All right. Well, it's equivalent to the y-coordinate, right? It's the same length of whatever this y-coordinate value is. So I'll also represent this by y. And what is the length of the side adjacent? What is this length here? Well, it's whatever the value of this x-coordinate is. So I'll write an x. Now, how can we represent the sine of theta? Well, recall our SOHCAHTOA. Where sine is equivalent to opposite over hypotenuse. So in relation to our angle theta here, the sine of theta would be opposite over hypotenuse. Opposite over hypotenuse, which in this diagram, the length of the side opposite is represented by the variable y, and the hypotenuse is our radius, which in this case is 1. So this is simply y over 1, which is equal to y. What's the cosine of theta? In relation to angle theta, adjacent is x, and again hypotenuse is 1. So cosine is adjacent over hypotenuse, which is x over 1, which is equal to x. And tangent theta, remember tangent, that's our TOA, opposite over adjacent. I'll write that out. Opposite over adjacent. In relation to angle theta, opposite is y, adjacent is x. So that's y over x. And, well, since y is equal to sine theta, and x is equal to cosine theta, tangent can be expressed as sine theta over cosine theta. So sort of three new things to remember. When you're looking at a point, the coordinates of a point that is on the unit circle, the y-coordinate is equal to the sine of your angle, the x-coordinate is the cosine of your angle, and the tangent of the angle is equivalent to sine over cosine. So any point xy on the unit circle can be found. Coordinates x comma y is equal to, the x-coordinate is equal to the cosine of the angle, and the y-coordinate is equal to the sine of the angle. All right, think of it alphabetically. All right, x comes before y in the alphabet, c for cosine comes before s for sine in the alphabet. So x-coordinate is equivalent to the cosine of the angle, y-coordinate is equivalent to sine of the angle. It's very important to remember that. If point P, having coordinates x, y, is a point on the unit circle, as long as it says a point on the unit circle, it's on the unit circle, then the x-coordinate is equal to cosine of the angle, and the y-coordinate is equal to the sine of the angle. All right, so other random angles with terminal side passing through point P on the unit circle. Again, these are on the unit circle, all right? The coordinates of this point on the unit circle has an x-coordinate of negative 0.7 and a y-coordinate of positive 0.7. What is the sine of this angle? Well, the sine of this angle is its y-coordinate. Cosine, sine. All right. So the sine of theta is 0.7. The cosine of theta is negative 0.7. Simply the x-coordinate. And the tangent of theta would be sine over cosine, 0.7 over negative 0.7, which is equivalent to negative 1. Here's another point on the unit circle. The coordinates of this point is 0.866, comma, negative 0.5. What is the sine of theta? That would be the y-coordinate, negative 0.5. The cosine is the x-coordinate, 0.866. And the tangent, sine over cosine, negative 0.5 over 0.866. It's approximately negative 5.77. All right, and the third one here. We have a point on the unit circle, x-coordinate, negative 0.87, y-coordinate, negative 0.49. Right? Both coordinates are negative, so you see here where our angle terminates in quadrant 3. If I go back, and positive x, negative y value puts us in quadrant 4, and a negative x and a positive y will place us in quadrant 2. What is the sine of this angle here? Again, it's the y-coordinate, negative 0.49. The cosine of our angle is the x-coordinate of this point, negative 0.87. And the tangent would be the sine over cosine, negative 0.49 divided by negative 0.87, approximately positive 0.56. So very important. If the point is on the unit circle, the x-coordinate's the cosine of the angle, the y-coordinate's the sine of the angle. So finding sine, cosine, and tangent, case 1, point P is on the unit circle. Again, as long as it's on the unit circle, then the x-coordinate of that point is equal to the cosine of the angle, and the y-coordinate is equal to the sine of the angle. OP is the terminal side of theta. Point O is the origin. So what do we have here? We have OP is the terminal side of the angle. Let's say it's here. Here's point P having coordinates x, y. It's on the unit circle. Here's the initial side of our angle. Here's our angle theta. What we want to do is we want to find the sine, cosine, and tangent of our angle, and also name what quadrant our angle lies in. Again, when the point is on the unit circle, use the x-coordinate is equal to the cosine of theta, and the y-coordinate is equal to the sine of theta. So here for number 1, point P has coordinates 9/41 and 40/41. So what is the sine of our angle? The sine of our angle theta would be 40/41, the y value. What's the cosine of our angle? It would be the x-coordinate, 9/41. And what's the tangent of our angle? Tangent is sine over cosine, so it would be 40/41 over 9/41. And if the denominators are the same, 41, then they can just divide right out. It's the same as multiplying the complex fraction by the least common denominator of 41. They divide out. So simplifying, we have 40/9 as the tangent. What quadrant is point P in? Well, both values are positive, right? Positive cosine value, positive x value, positive y value. That would be quadrant 1. Number 2, you might just notice here, I just finished up with quadrant for number 1. So here, our x-coordinate is negative, and our y-coordinate is also negative. In what quadrant are both x and y coordinates negative? Would be here in quadrant 3. So quadrant 3 is where our point P would lie. What is the sine of our angle? Well, it's the y-coordinate, -7/25. Yes, it's this easy. What's the cosine? It's the x-coordinate, -24/25. And what's the tangent? It's going to be sine over cosine. Just write that, because we need to remember this. And the sine value is -7/25, and the cosine value is -24/25. Those 25ths divide out, and a negative divided by negative is positive, so that's positive 7/24. And number 3, our angle P has an x-coordinate of square root of 5/5. That's a positive value. And a y-coordinate of -2 square root of 5/5. That's a negative value. Okay, so what quadrant are we in? Where our x-coordinate's positive and our y-coordinate is negative? That'd be quadrant 4. What is the sine of our angle theta? That's the y-coordinate. So that's -2 square root of 5/5. And the cosine of our angle is the x-coordinate, square root of 5/5. And the tangent is going to be sine over cosine. So -2 square root of 5/5 all over square root of 5/5. All right, which would simplify to the denominators of 5 would divide out. And then one more simplification, the square root of 5's divide out. So this is equal to -2. Next, we want to look at some of our quadrantal angles and find their sine, cosine, and tangent values. Okay, so here our angle theta is 0 degrees. This is on the unit circle, right? This is 1, that's -1. This is a unit circle. Remember, whenever we're on the unit circle, the x-coordinate is the cosine of our angle, and the y-coordinate is the sine of our angle. Very important to remember that when we're on the unit circle. Okay, so what's the sine of theta here of 0 degrees? The sine of 0 degrees is going to be the y-coordinate, which is 0. The cosine of theta is the x-coordinate, which is 1. That's what I was looking to do. Sorry, this is the y-coordinate. The tangent is going to be sine over cosine, or y over x, which is 0 over 1, which is 0. Next quadrantal angle, 90 degrees. Theta here is 90 degrees. The sine of theta, that's the y-coordinate, 1. Cosine's the x-coordinate, 0. Tangent's going to be 1 over 0, which is undefined. Our next angle, this is 180 degrees. The sine of theta is the y-coordinate, 0. Cosine is the x-coordinate, -1. And tangent is sine over cosine, 0 over -1, which is equal to 0. Our next quadrantal angle is 270 degrees. The sine of theta is the y-coordinate, -1. Cosine of theta is the x-coordinate, 0. And the tangent is sine over cosine. -1 over 0 is undefined. And continuing on to page 7. Some more quadrantal angles. Remember, an angle in standard position whose terminal side lies on either the x-axis or the y-axis is called a quadrantal angle. The measure of a quadrantal angle is a multiple of 90. All right, so what we want to do here is mark our 4 points of a unit circle. And we don't have to always draw the actual circle, and oftentimes I don't, but let's mark the 4 points. This would be 1, 0. This is the point 0, 1. -1, 0. And 0, -1. Here we'd have an angle measure of 0, 90, 180, 270, and all the way around 360. Okay, what is the cosine of 180 degrees? Well, cosine of 180, just remember, cosine's the x-coordinate, 180 degrees, -1. What's the sine of 180? It's the y-coordinate, 0. What's the tangent of 180? Right? That's going to be sine over cosine, which is -1. Oops, excuse me, which is 0 over -1, which is 0. The sine of 270. Again, as long as just refer back to this right here. The 4 points that guide us in drawing our unit circle. Again, I did not draw it though. Right? 270 degrees. Sine's the y-coordinate, -1. Next, the tangent of 270. That's going to be sine over cosine, -1 over 0, which is undefined. The cosine of 360 degrees. Cosine's the x-coordinate, 1. The sine of 90 degrees. Sine is the y-coordinate, 1. Sine of -90. Okay, -90 is equivalent to 270. positive 270. Sine value, negative 1. And the tangent of 360, tangent is going to be sine over cosine, 0 over 1, which is equal to 0. All right, and the final thing we're looking at today is signs, S-I-G-N-S, in quadrants. And we want to remember all students take chemistry. It means the following, right? So, all students take chemistry. All, A, quadrant 1, quadrant 2, S for students, quadrant 3, again continuing counterclockwise, T for take, and then quadrant 4, C for chemistry. So we write down, we go starting quadrant 1, all students take chemistry. So in quadrant 1, all trig functions are positive. Meaning, so the sine of theta is going to be greater than 0, the cosine of theta would be greater than 0, and the tangent of theta would be greater than 0. They would all be positive. In quadrant 2, S for sine, only sine is positive, well, and it's reciprocal, cosecant. Only sine is positive. So that means that the sine of theta is greater than 0, but the other two, cosine and tangent, are less than 0. In quadrant 3, T is for tangent. In quadrant 3, only tangent is positive. Meaning that tangent theta would be greater than 0, and sine and cosine would be less than 0. And quadrant 4, C is for cosine. Cosine is positive. Only cosine is positive. Meaning cosine is greater than 0, tangent and sine are less than 0. Okay, so a little bit of practice. Again, signs and quadrants, all students take chemistry. All students take chemistry. Okay. Name the quadrant in which the terminal side of theta lies if sine theta is less than 0, meaning sine is negative, and cosine theta is greater than 0, positive. All right, I go to the positive. Cosine is positive in quadrants 1 and 4. Out of 1 and 4, in which one, quadrant 1 or quadrant 4, is sine negative? Sine is negative in quadrant 4. So we are in quadrant 4 for number 1. Just put Q4. Number 2, sine of theta is greater than 0, so sine's positive, and tangent of theta is less than 0. Tangent's negative. All right, so what quadrants is sine positive? It's in quadrants 1 and 2. And out of 1 and 2, in which one is tangent negative? Quadrant 2. Number 3, sine theta is greater than 0, meaning sine's positive and cosine is also positive. All right, both sine and cosine are positive. That's in quadrant 1, where they're all positive. Quadrant 1. Number 4, cosine theta is less than 0, cosine's negative, and tangent theta is greater than 0, tangent's positive. Well, tangent's positive in 1 and 3, cosine's negative in 3. So quadrant 3. Number 5, tangent theta is less than 0. Tangent's negative, and cosine's greater than 0. Cosine's positive. What quadrant are we in if cosine is positive and tangent is negative? Well, cosine's positive in 4 and 1, and tangent is negative in 4. So we're in quadrant 4. And number 6, sine theta is less than 0, sine's negative, and cosine is also less than 0, cosine's negative. So what quadrant are both sine and cosine negative? Well, they're all positive in 1, sine's positive in 2, cosine's positive in 4, so we have to be in quadrant 3, where sine and cosine are both negative. Okay, that finishes tonight's video.